Hello all, welcome to 21-day masterclass on VLSI design. Is my voice is clear? Can you guys see my screen? Today we are going to see about combinational circuits. Let's get into session. Combinational circuit is a digital circuits where the output depends on only the current inputs. It is a fundamental concept of digital electronics. They differ from sequential circuits in the way of they don't have any past inputs, it only depends on current inputs. And this is lack of memory elements means that react instantly to input the changes. The combinational circuits only based on current inputs only. This is the biggest difference between the sequential circuits. And then see adders. You can see here the truth table of the adder, and this is a logical diagram of the adder. The function of the adder is adding the current inputs like AB, and also after having the carry output, like it has two inputs, two outputs, like AB is input and sum and carry also. Like here you can see here, we can know that 1 plus 1 0, sum 0 carry 1, like that is the function of the half adder. And then we move to full adder. The full adder is a combination of the half adders. You can see here in the logic diagram, the combination of the two half adders is known as full adder. The function of the full adder is it having the three inputs like carry in and inputs like AB or PQ, and you can get also sum and carry in this full adder. Like you can see in the truth table of the full adder, in this half adder having the XOR gate, like XOR operation is both inputs are same means it will give 0, but both inputs are different means it will give 1, like this. In this based on this operation you will get this double ones, like if you input of the full adder is 000 means AB is 0, carry in 0, sum also 0. If the input having the 0 0 1 and sum is 1, why? Because after having the XOR gate, you can see here after having the XOR gate, in this XOR gate in this half adder it having XOR gate, the inputs of the XOR gate is like 0 1. In the truth table of the XOR gate is if you having the 0 1 inputs, output is a 1, that's why sum is a 1, carry 0. Like that function we will calculate the full adder. And then move to larger bit binary additions. It means these are the inputs like input 1, input 2, input 1, input 2, like that. We can by adding means if you having 0 0 means it will sum 0 carry also 0, or if you adding 0 1 means sum 0 carry 1. If you adding 1 1 sum 0, and we have to put carry on another terms like another inputs. This is a main basic procedure to binary addition. And coming to the subtractor, it same like the after like a same as subtractor also. You can find, you can see here the two inputs like 0 and 1, it is a minute and a subtractant. There is two inputs of subtractor like minute and subtractant. You can see here. If you subtract 0 minus 1, it can't happen. So we have to borrow the another input for 0 from the next element, like here, like this only. This is a main procedure for the subtractor. The logic circuit of the subtractor looks like this only. It contains one XOR gate and one NOT gate, one AND gate. By combination of these circuits, we can attain the subtractor circuit. and this is a 3-bit full subtractor. Difference one bar out. Bar out is nothing but what are the elements it given to the another element, like this element having the borrow in element, but in this element giving the element for other element like helping element. This is called borrow out. This is for borrow in, this is called borrow out. That's why in the truth table we can see borrow out. And then coming to the 4-bit adder. This is a 4-bit adder cum subtractor. It works like it can do addition and subtraction also. Likewise, if you give the 0 means it will perform the addition operation, and it will, if you give 1 means it will perform the subtraction operation. Like that, this is a ripple carry adder circuit. Up to this circle only it to perform the ripple carry adder. It means it consists of continuous full adder circuits. By using that we can attain a ripple carry circuit. This is a selection line for the condition. If you give, I already said no, 0 means addition, 1 means subtraction. Like if you give the example like selection equal to 0, selection equal to 1, we have selection equal to 1. Input are 0 0, a equals 0, b equals 0. It means this XOR gate having the 0 1 input, like 0 1 input. It means it will give the 1 output because of different of inputs like 0 1. It will XOR gate gives 0 1 means output will be 1 only. So in this gate giving the 1, like input are 0 1, if b is 0, we can and s equal to 1, 0 1 combination, it gives 1 output, and this input we can take 0 also, 1 0. It will the output for the this full adder, and by using the same procedure we can find the 4-bit adder cum subtractor. And coming to ripple carry adders, it will consist of the continuous full adders in the circuit. By using this we can we can add the n number of inputs, like we can, but there is a main disadvantage of the ripple carry is there is a delay in the circuit. Why? Because by passing the one full adder to another full adder, there is need for logic gate, so that we can say the ripple carry adder having the 2 gate delay. We will see in the upcoming slides. Like the delay is called as propagation delay, carry propagation delay. Because of in this circuit having the 4 full adders, it is like a ripple carry adder circuit. In this 4 full adder, we have to get output from C5, but it will take like 1 2 3 4 gate delays. Why? Because of every full adder circuit has passed the output to another full adder circuit, so that it will take a 2 gate delays naturally. So that here 2, here 2, here 2, here 2. Now totally 8 gate delays it need for it take to give output from to C5. There is a main bad thing in the ripple carry adder. Because of gate delays is very serious condition in the digital circuit. Because of delaying, if it having the delays, it means the circuit works like slowly. For that, to rectify that delay things, there is a look ahead carry adder. It will perform the fastly, because faster than ripple carry adder. Because of this having the combination circuits, like we can see here, this is a circuit for the look ahead adder. It means it get direct inputs like A naught, B naught, C naught. It is input for full adder. You can see it next to the second full adder, it having the A1, B1 input directly from the circuit, but in the full adder, this carry out must be given to this full adder. But by using that way, we get the 2 gate delays, so that there is a one circuit for combination circuit. In this circuit performs these full adder operations. We can get the carry in by doing these operations parallelly. This circuit works takes parallel time only. At the time it will perform all the actions. By using this way we can attain the delay free results, get delay free results. In this full adder we have to give this carry out to this full adder, but we can also get by these combination circuits, it having the A0, B0, A1, B1, C0. You can see here the increasing of inputs, because of we have to calculate the half adder circuit of it will looks like a common circuit, but it having the full adder circuit, full adder of the these three these all inputs. And then coming to this full adder, we have to give this carry out to carry in for this full adder, but in this, by using this circuit we will get the delay free results. These are the logic diagram for the look ahead adder. You can refer from this. This is the logic. I will show you. You can see here the input of the common circuit having A0, B0, C0 that are given to here only. Like this is one common circuit, this is another common circuit. By using these circuits, we get the correct results or delay free results. This is the main advantage of the carry look ahead adder. They are doing the parallel. I already said no. They are doing the parallel addition of the multiple bits can have the with a fixed amount of delays. Carry look ahead adder generate a circuit as the same 2 gate level delays for generating the carry for all the bits. It means it won't take it to get 2 gate delays. And the main disadvantage is we need to give a more logic gate for the circuits, like it having the additional combination circuits, so that we have to give extra logic gates for make these combination circuits, because of by here it only having 3 inputs 1 output, but here it having the 5 inputs 1 output. For that we have to give the n number of logic gates to perform that particular actions. This is the main disadvantage of the carry look ahead adder. And then coming to the parity check, there is a term parity. It means we have to measure the binary numbers, like it having the even parity or odd parity. By using this circuit, we can attain this even parity checkers. Like if you output of here it having 1 means it is an error. If you get 0 means it will correct. You can it is based on the even parity, means it having the even number of ones. Like you can measure like 0 0 0 1 0 1 0, like random number, right? Like random series of binary numbers. By using the XOR operations, final output must be 1 for the error. It will give the 1 means it is correct only. And if you guys interested in MASTERCLASS, you can convert it into the internship for 1 month. You will get the benefits of all 30 days recording sessions, all 30 days for presentations, and exclusive project codes. And you will get a community group for doubt clearing and internship updates. And you will get a internship confirmation letter from IETE. And also you will get access for LMS portal. And you will get assignment and tasks for your development of VLSI design. And we containing the weekly live sessions. And we will teach you resume building and mock testers. And you will get an internship and participant certificates. If you guys really interested, if you want this course, you can join. at discounted fee of 799 only. Our regular fee is 1999. You can get this course by using the registration link. Our organizer will post the link on chat box, and it is a limited time period offer. You will get. It will close 8 to 2024. It means next month of 2. If you guys really interested, please avail it. And then coming to the decoder. Decoder is a process of the identifying the presence of the specified combination bits. Like if you build a circuit, it perform only the whatever the binary code it have. Like that, if you want to output from decoder, there is one input only. How to say? It will identify the presence of the specific combination of bits, and its inputs indicates the presence of the code by a specified output level, and it is general form of the input lines handle the n bits. It having the 2 power n inputs and n bit outputs. This is the main functionality of the decoder by using the logic gates. Like if you giving the 1 means you will get the 1 output. If you giving the 0 means you will get the 0 output from using this gate. If you want to perform, you want to get 11100 output means we have to design the circuits in decoder. Like I will show in upcoming slides. Like this is a 3 input and 8 outputs of the decoder. Like if the inputs are giving means if inputs are having 00 means your output will be all the zeros only. The first bit of the output is 1 and remaining bit all the bits are 0 only. If you give it is the basic truth table for the 8 line and 8 line input and 8 line output decoder. If the inputs are having the 100, you will get this output 8-bit series. These are fixed only. We can't change the BCD because of BCD is very crucial and sensitive also. If we change it, the combination of the inputs, we will get wrong the outputs. So we have to follow these inputs only. Like if you give the 111, you will get the output of this 8-bit series, like 7 zeros last bit 1. And this is the implementation of the 8-bit 8x3 decoder, like 8 input, 3 input, 8 output. And this is a truth table for the 4-bit decoder truth table, like 4 input, 16 outputs. Like I already said, no, n is a for input, n equal to 4 means 2 power n is output. 2 power 4 means 16. So we will get 4 inputs, 16 outputs. In the free time, we will refer the truth table also, but it will take too much time to understand, like what are the changes in the outputs. And this is a logical symbol for decoder. It's basic thing. If you 4 input 16 output means if you give like this input 0 0 0 0, you will get the first line of the output. This is a basic operation for the decoder. And by our in our computer we access the printer, keyboard, monitor, scanner, that are variable devices. That these are based on the decoder only. But every decoder having separate number, like every variable is liking a separate address, like this address. If we giving this inputs only, we can access this address. Like in this the 0 1 having, if you give the input from input in A0 like 0 0 0, you can access the printer. Why? Because it having the decoder perform like that only. so that decoder user for access the peripheral devices in computers like printer, keyboard, monitor, scanner, and etc. And coming to the encoder, it is the reverse of the decoder. The encoder accepts the all level of active level of one inputs and representing in a digital such as decimal or octal or converts into decoder. It having the 2 power n inputs and n outputs. It means it is reverse to decoder like that. It having the 2 power n. 2 power n means if you n equal to 2 means 2 power 2 4 inputs you will get 2 outputs. Like that in it having the 2 power 3 input, 2 power 4 input and 4 outputs. You can see here decoder schematic and circuit of the 4:2 encoder. Encoder means 4:4 means 4 input and 2 output of the encoder. You can give input for the encoder like 000, you will get output of 00 only. This is a logic diagram for the encoder. And this is a truth table for 8:3 encoder. It has 8 inputs and 3 outputs of encoder. If you giving this input to encoder, it will give the output of 00 only. Why? Because the circuit is based on OR gate, like adding all the 8 ones. And then coming to the multiplexer. Multiplexer is, we all know that multiplexer is performance of the multiplication only. But this multiplexer performing the binary multiplication. It need to for that it need two data set inputs, like if the input having the if the multiplexer having the 2 inputs, it need one data cell lines. If the input having the 4 inputs, it have the must have to give the 2 cell lines, like here only. If the mux having the 2 inputs, we have to give 1 cell line for the mux, because based on the selection line we can access the mux only. If you give the s equal to 0, we can choose this line to output. If you give the s equal to 1, the one line given to the as output. This is a basic structure of the mux 2x1, and this is a logic diagram for that. This logic diagram performing the mux operation only. And then we can see here for 4 input 1 output mux 4x1, 4 input 1 output multiplexer needs a 2 selection lines. Based on the selection lines we can get the data. If the selection lines having the both are 0 means we can get first line output, like this only. If the inputs having the 0 means this input act as a output, it goes to output. And if the inputs having the 1 means the second input get the output. And if the inputs having the 0 means the third line gives the output to the multiplexer. And if the both inputs having 1 means the fourth line give the output for the multiplexer. Same while 8x1 mux also works like same 2 4x1. But the 8x1 must having to 3 selection line. Why? Because we can count these 4 inputs by using the 2 bits of the signals. We can do that, but we can't count the 8 outputs by using the 2 selection lines. So that we need to increase the selection lines for the choosing the input lines of the mux. This is based on 2 power n calculation. If the inputs having the 2, we have to give the one cell lines. If the inputs having the 4, we have to give the 2 cell lines. If the inputs having the 8, we have to give the 3 cell lines for the multiplexer. And this is a multiplexer we using for making 4 inputs 1 outputs by using the 2x1 multiplexer. We can get also 4 inputs 1 outputs multiplexer by using the 2x1 multiplexer based on these circuits only. Here I already said no, 4 inputs must have two selection lines. In that we have to give selection lines for this mux1, S1, S2 and S0. Based on this circuits we can get these output values. Like you can give here if the selection lines, if all the mux are having the 0 1 0 1 combination, A B, here you can see 0 1 0 1 0 1 0 1. If they give if you give S equals 0 means the zeros to data come out from this mux, and here you can give also 0 means this 0 will come out from this mux, and here also you can give 0 means you will get 0 out from this mux. Both after that you will get the 0 0 of the output as output. And this is a circuit for the 2x1 mux using 4x1 4x1 mux using 4x1 2x1. Like we can achieve the half adder by using the mux also. It means we can attain the functionalities of the half adder by using 2x1 mux and 4x1 mux. This is a function. This is a logic diagram for the 4x1 mux for the half adder. Based on the inputs are given as a selection like A and 0. Half adder performing the addition operation like sum and carry. There is a half adder having the 2 outputs like sum and carry. The sum doing the operation of the XOR operation, and the carry having doing the AND operations of the inputs. If we give the input like 0 0, the sum will be 0. It will go to here. First we see the 4x1 mux of the sum operation. 0 0 means it will choose this line. Because of this line only having 0 0, this line only having the 1 0 0 1, this line having the 1 0, this line having the 1 1. If you give the 0 0 means it will choose this line 0 only, sum will be 0. In this mux, if you give the 0 0 means it will choose the 0 this line only. For that other combination like 1 1, if you give the 1 1 for the inputs, it has x having 1, y having 1. In this mux, if you give 1 1 input, it will choose this line sum 0, and here inputs are 1 1, it choose this line, you will get carry 1. Like the same only it's a half adder operation, sum 0 carry 1. Based on this circuit we can attain all the circuits like half adder, full adder, triple carry adder. The muxes can do all the logic gates of logic gates. So that that's all today. We also see the next day of sequence. We will see the sequence circuits of next day, and then we will move to Verilog upcoming days. Thank you for listening.